So we talked about various things on switched capacitor circuit. So how much noise of the power you are expecting from one switch cap, Siddhant? Yeah, power of noise in one switch cap circuit. How much you are going to expect? So power amplitude or right. So it's KT by C generally. This is what we learn, and we also learn that there are two kinds of noise. There are more than like these two noise are available, but the low noise, not low noise, noise at low frequency and noise at high frequency. So at low frequency it's 1 by F or flicker, both are same, and high frequency is generally thermal noise, thermal noise, right? Other than that, there are other noise are also available, such as short noise, popcorn noise, pink noise. So many noises are available. So we are not covering that. However, for the better understanding of noise, one should study that also. And you can refer many good books are available. You can refer Behzad Razavi, but whatever I referred, I covered that is from Behzad Razavi. If you want to go further, you should take another book, not Behzad Razavi. There might be another book which can cover more theory on noise. Few more things we also learn, and those things are charge injection and clock feed through. This is happening because of the reason that switch is off, but still it's not off. It's also contributing something in terms of charge, or the clock is actually still connected at the output capacitance through the parasitic capacitors, and you can observe the clock. So that is clock feed through and charge injection. To remove this, we can use dummy switches, which has to be carefully uh, carefully it has to be designed. If this is the case where you have one dummy switch. If this is phi, this has to be phi bar, and this, this is ground by the way. If this is W by L, this is hold capacitor. What will value of transistor I need to take? Hmm? Double, right? 2W by L, just to make sure that it will cancel the exact. Is it double or half? It has to be double, right? Right? So it's double, so that you are going to have, actually, sorry, W2 has to be half of W1, not right. So it has to be half of W1. One can double the length also. Both are same, right? Okay. So these are the things we already studied. Okay. However, there is a like few things which has not been covered completely, although it's already known to you. If you want to design a switch, that switch might be NMOS, might be PMOS, or might be transmission gate. Right? When should I use NMOS?
So when we have connected one end with ground.
One end with the lowest potential, right? So low potential, if this side is low potential, then you can use this one. If you are using PMOS switch, so one side is higher potential, then this side can be connected to PMOS. However, if you do not know what is happening and if you are associated with low and high both, or swing is full, then you can use transmission gate, right? This might be 5 bar, this might be 5. And if you are using anywhere switches, remember switches are going to invite charge injection and clock feed through. One more thing, if there is even a single switch, it's equivalent to one resistance and capacitance, so it's going to contribute switching or switch noise, which is equivalent to KT by C or equivalent to thermal noise. So by increasing the value of W, you can increase the value of capacitance, and you can actually take care of KT by C by just using the W band, right? So all these things are happening when you are in a scenario where all these things are actually the constant values, right? When there is a clock, it is like this, where in one phase it's 0, one phase it's VDD, right, Nishant? So one phase 0, one phase VDD. So basically in these two phases, it's constant value. That is what connected here. Similarly, what you want to transfer, that is also some fixed value which is known to you. If this is ground, if this is VDD, no problem. If this is full swing, sine wave, no problem. But the problem is this resistance of any switch. How much it is if it is NMOS? Hmm? Yes, R on of any switch, because the base switch is the one when you are going to be in the linear region. Here, switch is the best when you can have this one is in linear or triode region, not in saturation, right? That's the best case. So if you are interested in that, what will be the switch resistance? 1 by mu n C ox W by L VGS minus VTH. So if your VGS is varying, this whole thing is also varying, and it's not stable one, right? So such kind of structure is going to give you problem, where your input is moving, or maybe your gate is moving, or I should say VGS is actually variable. If VGS is variable, then you have to change different scheme than what we have used just now. In that case, what you need to do, if this is the circuit where this guy is connected to VDD, when I'm interested to transfer the whatever input is there, I want to transfer that. So in that case, I can use, let's say, right now I'm using some NMOS, but this VGS is varying, right? So this switch is not going to be helpful because VGS is varying, and you cannot have exactly whatever being you want because of the non-linear behavior of the resistance. It's not linear, it's non-linear. So if you want to do that, the technique says if VGS is constant, then there is no problem. To make this VGS constant, what I am doing, rather than doing this, maybe I can add one battery which is equivalent to V in, and this side I am going to see VDD plus Vin. So in reality, VGS is equal to VDD, right? So how to make this? If you want to use VDD, we are not going to use VDD, but what we are going to use? We are going to use a big capacitor. Let's call this as some CVDD, which is going to store VDD voltage. And let's assume that its initial condition is already VDD. So in that case, I want this capacitor to be present only when I want to take this sample, not during the hail time. One time it's V in, one times it's one times it's sampling, one times it's actually holding. So during the whole time we want all these things just to make sure that it's holding what we want. So during the phi 2, this capacitor which is charged with the VDD has to be in series with Vin, and you should see here Vin plus VDD, right? However, in other case, what I want this to be done so that this capacitor is charged to VDD, but there is a fault over here because this gate is not connected to any potential when phi 1 is there. So what I can do, I can apply here one more switch and keep it to ground, and let's call this one as phi 1. So during phi 1 time, this potential is connected to 0. During phi 2, this potential is connected to Vin plus VDD, and this action will make sure that this capacitor will not discharge, and we need to take care of all these switches such a way that the resistance offered by these two switches multiplied by C times VDD is much lower than the time constant at which we are operating the clock, right? So this is what we need to take care. Now the next thing is, let's replace these switches which we have made with the normal notation. Let's replace with different switches of transistor switches. So what do you think? What should I do with phi 1? So I can use NMOS, no problem. What about this guy? What about phi 2? So it has to be transmission gate. Right. Now what about these two? Let's start from here. Or let's start from here. Why? Look, you are adding one extra transistor. So if you can do it with, here there was a full swing. Here there are fixed voltages. There is no swing. You are at one side, right? This side is Vin plus VDD. Actually, this side is Vin plus VDD, which you want to transfer here. So as he has rightly pointed out, you can have PMOS. But the only problem here is this side is Vin plus VDD. What is going to happen to this guy, which is body? Till now, here there was no problem. Look, there was no problem. VDD and ground and all, because all NMOSes were connected to, body of NMOS was connected to ground, and body of PMOS was connected to body VDD. So what will happen to this body? Because if I am connecting to VDD, this is connected to VDD. Oh, sorry. This is Vin plus this. Okay, this is also VDD, and you want to give something Vin plus VDD, and you are expecting something Vin plus VDD. Is it possible to have? Why not? I don't. This is what I'm teaching even undergraduate students, that if you have op amp, you cannot go beyond your power supply, right? So what is the supply for this particular? So you cannot go beyond VDD, though your output, the base case will be VDD. So in that case, you need to change the supply. Maybe you can connect these two here, just to make sure that you can transfer Vin plus VDD, right? So in generally in different design of like digital, generally we don't do such thing, but in analog circuits, many places we are doing this. Or if you are actually working at high speed, you are going to tie the source with body, just to make sure that source and body are actually at the same potential. However, there is a something called body effect. So body effect is also one which is known as gamma, which is going to change VTH, which has not been incorporated right now. But at the base case, you can do source and body short, and even if there is some delta VTH, you will make the budget, and maybe some delta change you will observe here. But this is the base thing, we can do it. Otherwise, we have to do something else for compensating that. Now, what will we switch over here? VDD I want to transfer here. But here, if I am using PMOS, if this is connected to, first of all, this has to be phi 2 bar, because this is PMOS. So if I am connecting this to phi 2, the only problem is, again same, body is connected to Vn plus VDD, because here the output is Vn plus VDD. You can see that, right? So you can think about it. I'm keeping this thing to you. If you know where to connect this body, then you know the whole circuit diagram. This circuit diagram is known as bootstrap switch. So it looks very simple, but just to get one sample and hold, or just to get V in over here, we are doing all this jugglery, right? Okay, so this will complete the implementation of all the switches. Yeah.
For transmission gate, whether we connect the body to source or body for NMOS body to ground and PMOS body to.
So if I am not drawing, means NMOS body is connected to ground and PMOS body is connected to VDD. This will make sure that you are not going below ground and you are not going above VDD. This is defining the power supply, right? So same thing you can do here. If I am connecting this to ground and this to VDD, no problem, because input is actually between V, maybe from 0 to VDD.
Practically also we will do the same in layout point of view also.
Yeah. So practical point of view, I'm talking about all the things are practical point of view. Otherwise, you can use simple switch like this, which will so practically you have to implement such structure. which will make sure if V in is equal to V out. And so maybe that's the next topic which I want to teach or want to tell you. Okay. Okay. So can you tell me what are the input and output impedance very quickly when the switch is on? What I think. When switch is on, you're going to see 1 by GM, right? Yes or no? When looking from, actually, either you are looking from drain side, source side. If it is this kind of structure, you are going to see 1 by GM, right? And this side also you can see that, right? So this was just a, in between. So after applying these all these things you can find out. I'm not going into all these things. Okay, but the most important part was, if you want to realize a resistor that can be realized using a switch cap circuit where there are two switches S1 and S2 whose phases are 180-degree phase shifted, right? One is phi and one is phi bar. Then you are going to see the resistance which is equivalent to 1 by FCC or maybe TC by C. TC and FC are the clock uh, phase of the, or the timing or the hertz of particular clock, right? So that is what you can implement it. Yeah, both sides there are two different voltages. I don't understand your question, by the way.
Sir, it will not act as simple as resistor. It is acting as sample and hold. It will sample the whole.
But you already agree this. Do you want me to take the whole lecture again? What we have started, or I don't know. Like you are going into different thing. No, you don't agree with this. You don't agree with this maths. Hmm. Hmm.
Okay, but will it act as a normal resistor?
Why not? What is your reasoning?
Shape of how will not be the same as the.
Look, first of all, there is VA and VB. There are two things. Can you see? Look at the analogy. VA and VB are the voltage sources, and you are replacing that with some switch cap arrangement, which is going to give you the resistance on the basis of this. I'm following the maths. I don't follow any philosophy. Right? We already proved this. Right? So if I want to make a switch capacitor based integrator, it's same as, by the way, this is copied from Behzad Raza. We already talked about all these things, right? It's same as what we studied. So junction capacitance at the input creates non-ideal effects, as pointed out by Nazrul. I don't know whether he wanted to tell that or not. The resistor which you are seeing might not be the linear resistance which exactly seen there. You might have some different things, or it is depending on the frequency. Look, there are lots of depending parameters, and it's not only capacitor but capacitor which is connected here plus some parasitic capacitor, right? So junction capacitance at the input creates non-ideal effects. So how to remove junction capacitance non-ideal non-linearities? Increase the length. You can increase the length. You have to play with W and L. There are only two things which you have, so you can do that, right? This is okay. CMFB I'm just keeping. Okay, so when we are talking about non-linearities, so non-linear things are the one you want to see such kind of input and output relation, right? But instead of this, if you are seeing something like this or this, all these are non-linear, right? So depending on what order of non-linearities do you have. Do you understand, by the way, what is non-linearity, or yes or no? What is Nishan?
Presence of harmonics
Hmm.
and
So
the input and output relation is not defined.
so if this is the equation, when c equal to 0, that is the linear equation, we understand. So again, I'm telling you, Nazrul, I follow only mathematics. Don't look at it any philosophy. And before telling that, you should give me any reason also. If you're saying it's wrong, right? It's a big statement that you're saying it's wrong, right? If you're saying something, if I am wrong, you should give me some reason, right? So, right? If you are having following kind of equation where y is output, x is input, and c is initial condition generally. So if this is the case, this equation is non-linear, or you are having higher order polynomials, right? So in m1, m2, m3 are slow, and x square is square of the, like, x is a sine omega t, then this has to be a square sine square omega t. But this is now this is not the way to represent all the polynomials, but um, so it's modified equation which we have already studied, and there is nothing like c, but c will be there. So if this is the case, when I'm replacing x equal to a cos omega t, one can use sine omega t also. It's not a much difference. So it's alpha 2 times a square cos square omega t, which is following mx plus m1 x square plus m2 x cube, right? So this is what we are seeing when we are replacing x is equal to a cos omega t. So it's going to be alpha 2 a square by 2 1 plus cos 2 omega t, and you can write down everything in terms of 2 omega 3 3 omega t 4 omega t, not in square and cube uh, cube thing. You will going to write down omega t 2 omega t 3 omega t, that can be replaced by simple thing which is already known to you, right? Because cos square omega t is 1 plus cos 2 omega t divided by 2. Cos cube omega t is 3 cos omega t plus cos 3 omega t divided by 4. So this is going to give you something like alpha 1 a cos omega t plus alpha 2 a square by 2 plus alpha 2 a square by 2 cos 2 omega t plus alpha 3 a cube by 4 times 3 cos omega t. This is one equation. This is, and alpha cube a cube by 4 cos 3 omega t, right? So first harmonic, or the fundamental thing, is going to tell you what is the amplitude. So the multiplying factor, which is alpha 1a plus 3 alpha 3 a cube by 4, then alpha 2 a square by 2, which is at zeroth frequency, right? This might be here, alpha 2 a square by 2, and third will be alpha cube a cube by 4. So the most important part is how many harmonics needs to be taken into account. How many harmonics I need to take?
So up to 8th.
Why 8?
So because after 8th harmonic, the power contribution after 8th harmonic will be negligible.
Okay, but why do you think only 8? Still 8 is some magic number.
I think I heard somewhere that the power distribution curve.
What you are saying is correct, but it's on the basis of some assumption. That assumption says your input is, let's assume that my input is somewhere around, so this is an amplifier which is non-linear. I'm giving here say 20 microvolt. This gain is around, let's say, 10 times, and I'm seeing 200 microvolt. So at output here, because of this non-linear effect, I'm going to see 200 microvolt. I might be seeing something else here, something here. So these amplitudes are keep on going down, right? So this is amplitude versus frequency, as you are saying 8. So I'm giving you some different number. If you are working in cadence, you cannot see anything below, okay, below minus 300 dB. Anything minus 300 dB is, that's the, the base case which you can achieve, right? In cadence, noise floor. The minimum amplitude which can be seen, it's minus 300 dB. If you are saying anything other than minus 300 dB, let's say if you are saying minus 6 kilo dB, this is very very common, and it will say that you have done wrong thing. Okay, if you are saying minus 6 kilo dB, means you have done something wrong. Any comment on this? Okay, so minus 6 kilo dB means your output is connected to be floating. It's not connected anywhere. It's as good as zero. Or how much is minus 300 dB, by the way, Nazrul? How much minus 300 dB in volts? Volts mean volts. dB to convert it to voltage. You have to give me the answer. What are you talking about? Minus 300 dB to volts. 1 femtovolt. Excellent, right? So 10 raised to minus 15. Okay. So it's 15 is multiplied by 20, and so you have to be quick in this mathematics. So 1 femtovolt. Now, after 200 microvolt, let's assume that this is available at 20 micro. This is connected at 2 micro, 0.2 micro. Then let's say I'm keeping 10 times everything, which is not going to be the case. Even it will be much lower than what I'm doing. What about this one? So you have to see the point when you are going to reach minus 300 dB, because afterwards it's inside the noise floor. However, if this signal is very high, and if you are not reaching minus 300 dB even after 8 harmonic, if you are reaching it after 16 harmonic, then you have to take care of 16 harmonics, right? That is how it should be. It has to be higher than noise floor, so you have to define some noise floor. So in generally in cadence, you are going to see minus 300 dB. We know how to do take FFT. You know what is FFT? Okay, so what next? I suggest if you haven't done it, we haven't learned it. Last semester we haven't taught them. No, I'm asking Dinesh and Indu. In analog, I haven't taught. Okay, it's fine. So that's good. So we are in flow. So what I suggest, take one sine wave, right? Take one sine wave in cadence. Just do this exercise. Find out the FFT of sine wave. So what are you going to expect if you have sine omega t? By the way, I am using sine wave, but all the books are following cos. Why they are following cos? Why they like cos?
Real part related to some real part because when if we express the cos is representing the real part
Hmm.
and sine is representing the imaginary part.
So I should not take sine. Mm. No,
Like
why all the books are following sine and like all the books are following cos, but still I am talking about sine. You can take any one of them; it's not a problem. But why they have taken? I thought about it, and it's not given in any book. But I thought, and I got some answer. I don't know whether it's correct or not. What do you think?
Consequently, only
Okay, let's include others also. Let's Dinesh, Indu, Himanshu, all.
even
So,
so the spectra will be symmetric.
so what? You might be correct. Dinesh, do you want to add something? Shubham is on right track. Chalo. Okay, so what?
Sir, when we are taking the axis, so
So what?
sir, it will
I
be
understand. It's even function. It's period. Yeah.
Sir, I have seen when I was studying the filters.
Hmm.
In filters, when we plot that the two-sided with this and
But it's a different thing. What you are saying is different, no?
in this case we can represent this cos this way, but in some case
Okay.
it would be
So
like
correcting to maybe to Siddhant. So what you are saying, it's different thing because in that you are plotting magnitude plot which is already mod. So sine is also no problem. Sine is mod will be similar side, right? So it will kill your reasoning first of all. So Shubham was correct, but so I was thinking similar. So what do you think? There is something called SSB. And you heard about this DSB? So if you want to have a single side bed, through single side bed itself, you can recover the whole information. So that is only possible if it is cos. If it is sine, it's not possible. This is what I got the answer. Like this is my invented answer, right? So any other thing which you can think about? I don't know.
Sir,
Yeah.
as you said, like the minus is not a problem. So
It's a mod, so it's a minus 1/2 j. So it will go.
the same information as compared to the positive.
Sometimes it's confusing also, right? In communication, right? Plus and minus you cannot alter them easily, right? But in cos it's happening, right? So now let's assume that if it is sine or cos, but you are feeding 1 megahertz. Okay, how is your signal and system, Raman? Signal system, huh? What is your strong point? What is your strongest point? Maths. You should find out some of your strong point. Have you seen Chandni Chowk to China? Akshay Kumar hota hai, right? At least he knows how to make aloo paratha very quickly. So if it is 1 megahertz, some sine or cos, so what are you expecting in the frequency domain? 1 megahertz, 1 volt. I want to draw this in dBV with respect to frequency. This is the simplest thing I can ask, right? Now tell me. Impulse where? So this is 0 dB V line. So how much is 1 volt in dB? Nazrul. How much is 1 volt? Yeah, so 0. So now tell me, what are you going to observe if we have 1 volt 1 megahertz of signal? If you are simulating that, and if you are looking in frequency spectrum, what are you going to see? There is no point in doing all this mixed signal and all if we don't know how to, like, what is the spectrum. You were, yeah, simply, yeah, he got the correct answer, that's why, okay, I'm asking.
It would show simple dot.
Simple dot where?
At
Here.
yes.
Oh, I understand, you mean to say, okay, you don't like this actually dBV. Okay, let's make this one as linear, then we will transform it to dBV. Okay, now tell me, Siddhant. 1 volt 1 megahertz. So now tell me, if there is a sine omega t where frequency is 1 mega and the amplitude is 1 volt, what are you going to see? Impulse of 1 volt at 1 megahertz, right? This is what you are saying. This is 0. Now I want to transform whole thing in dB. Whole thing in dB. So this will go to 0 dB. Right? It's V, so it's V. How to convert this 0 from linear scale to dB? That is what you are doing, right? That's how you shrinked here, which was actually wrong. Because 0 dB is equal to 1 volt. Do you agree? 0 dB is equal to 1 volt. In linear scale, you are drawing this one. Then and then 0 dB and 0 dB both will be at same place. That's how it will become dot. But I want to draw this one where I'll convert this 1 volt to dB, which will become 0 dB, and I'll convert 0 to dB. So tell me, what will be the 0?
It will be from 0 dB line to the negative.
Where? 0. I need 0. So 0 is possible in logarithmic scale? No. So there has to be some number. That number I already told. Let's keep it minus 300 dB, which is by cadence, which is 10 raised to minus 15. For the case of MATLAB, maybe 600 dB minus 600 dB. Right? What are you going to see in rest of the places? What are you going to see rest of the places? So still 0 is not at 300, even much lower than 300, right? You can take some minus infinity dB. That will give you 0 in reality, right? So what will happen to other places? At 2 mega, 3 mega, what are you going to see? No, we are not passing. This is just a sine wave. We are checking here. It's independent source. Why noise? It's independent source. You are simulating, so you are expecting 0. So everything has to be at minus infinity dB. But as cadence has limitation, it cannot show something like minus infinity dB. The noise given by cadence will be at minus 300 dB as well. So you are going to see following things. Right? There's some specific reason I'm drawing the green line. All good till now. So you are going to see this one. If you have never done it, it will not happen immediately. That's the most difficult part. Right? Okay. So I suggest let's add this one as your one of the, like, let's add this one in as a part of your comparator evaluation also. Huh? So do not teach them. So you teach on your you get learn by yourself. You can look at the literature or wherever you can find out. So DFT you need to use. This is the function. By the way, what is the difference between DFT and FFT?
Number of samples, I think.
No, DFT has also samples.
So FFT uses a lot of approximation.
Okay.
While DFT less approximation to
Okay. Just for your information, FFT is derived from DFT. Okay. So now tell me. DFT is superset, FFT is subset. So of course there will be some approximation. So what is that?
DFT says like using some point, not all the points, we can extract the same information from this one.
Okay. First of all, let's go to DFT. What is DFT, by the way? So what is DFT? Not the name only. Huh? Mapping of time to frequency. Okay. But we could have what you are saying is actually Fourier transform if the signal is not periodic. If it is periodic, you can call this one as DFS or FS, Fourier series. If it is aperiodic, Fourier transform. So now tell me how this D is coming into picture. Discrete Fourier series and discrete Fourier transform. You see. So we are sampling at specific time domain. It's not happening from here to here, but you are going to sample it. For that you are going to follow Nyquist, right? And then you are applying all the theory of Fourier series or Fourier transform. Whatever you are getting, DFS or DFT, cadence understand only DFT, right? Both are equal to DFT, right? For cadence, even if it's periodic or aperiodic. Now, so DFT we already found out. So what is FFT? Now tell me, Nazrul. Not the full form. We already discussed that. Hmm? I'm not asking the advantage of DFT over FFT. FFT is most superior because of something. I don't know that. So you people have to tell me. So what is the difference between DFT and FFT? This is the reason why I kept a DSP as a, the core course in first semester, and thereafter we dropped it because nobody could perform very well in previous years in MTech VLSI. So what do you think? What is FFT? So DFT you must have studied in your BTech in different course, not in DSP. DFT is part of maybe signal system. Signal system, okay. Signals and system. In FFT, we are studying in DSP. Yes, or because I'm sharing my experience. If you studied somewhere DSP, then DSP is talking about FFT. DSP is all about how you are going to implement all these things which you learn in signal system, which is digital or discrete, to the the domain which is going to make the simulator for you at the end, right? So FFT is an algorithm through which you can implement DFT, right? It's an algorithm. There might be many different algorithms like radix to butterfly, right? There are many algorithms are there. So if you studied DSP, then it's part of that. But we are not going into the algorithm of those things. If you want to study, you can study separately. But Cadence is going to do it for you, and it will find out FFT by doing something on DFT. So the DFT is first of all the sampled system, right? When you are taking the DFT, in reality, you are going to take the DFT from minus infinity to plus infinity on paper. Are you following this, right? But if you are doing it in simulator, you are not doing it for minus infinity to plus infinity. It is not happening at all. So what you are doing, you are taking a small photograph, and for that photograph I am going to take the Fourier transform or Fourier series. This signal is continuously coming, but I am doing it for a fixed photograph. Technically, you can call this photograph as window. And after running this, so many windows, one after one, if you are adding all of them, this is called autoregressive moving average, ARMA modeling, right? That is how you must have studied somewhere. If you have studied DSP, if you have not studied DSP, you cannot follow any one of the thing. But this is how it happens, and you may have different windows. Not only this, if you are taking this window, it's a rectangular window. Right? So if you are taking rectangular window, and you know that from here to here you are counting all the samples for a given value of sine wave or maybe cos or anything. If you know the number of samples which you need, then you can find out the spectrum of frequency. So it's not straightforward that if you are applying DFT, you are going to see this one, but if you are applying DFT, you are going to see this one. Those who have done it like earlier, yeah, Dinesh and all, right? I gave this exercise to all my students till now, and they got something like this. Even let's make it better than what exactly you are going to see. You are attempting to get the best FFT which you can achieve will be look like this one. If these numbers are wrong, these are very specific, and to achieve minus 300 dB needs real mathematics, for number of clock cycles, number of samples. Even sometimes you have to skip some of the cycles, because initially you will get something like this. So you have to skip something. Maybe you can skip one or two windows and then you can check the output, right? So all these things depending on your expertise or understanding of this particular spectrum. So first of all, by looking at this, can you tell me how many cycles I am plotting right now? So if it is a good FFT, no problem. Nishan, what do you think? That's how I kept some green lines also. So this is one hint, huh? Yeah, so look, I can simulate this one. I can simulate this one also in my window, right? I can simulate this one also. all will have different spectrum. Look, because you are sampling, when you are sampling on top of another sampling, you may have this one also. So what do you think, Nishant, Shubham?
Two cycles.
Right now it's one cycle. Right now it's one cycle because 1 mega, 2 mega, 3 mega, it's coming, right? And these are two cycles. And where you are doing this is last point is fs by 2. This is done for 1 2 3 4 5 6 7, let's say 8 somewhere. This is 8 point fft, where sampling frequency will be exactly equal to 3 mega. If you are not doing this, and if you are doing something here and there, some delta change, even with, if you are supposed to do this one, let's say, and if you are doing this one, you are going to see such kind of things. Okay, so you have to be precise. So as I told you, just adding to what I was trying to teach you. So if you are trying to get the best result, but still that result is not based, let's say this is 300 minus 300 dB, and if you are getting something like this for a single sine wave for 4 cycles, right? You can see 4 cycles, right? By the way, each point is known as bin, and this whole process is known as binning, right? So when you are doing these things, if you are seeing such kind of things, you can declare that one as Eiffel Tower effect, okay? Because it looks like Eiffel Tower, okay? It's Eiffel Tower, and this is as good as, so we don't call someone that your FFT or DFT is wrong. We are going to call it your FFT is leaky, right? These are the technical words I'm talking about, right? So your FFT is leaky, so we don't want to see any leaky FFT. We want to see only one, you know, fundamental signal at whatever frequency you are giving. Rest of the things has to be at minus 300 dB, right? So this is what you need to do. So how to find out these numbers, algorithms, it's up to you. There are many other windows like Kaiser, maybe any Henning window. Other windows are also available. Blackman Harris. So if you are writing these names, and these names are already written in Cadence. If you are going there in DFT, you have to choose any one of them. Right? So these names are already given. So if you want to understand what is these windows are, so depending on the shape of the window, because like one normal thing, normal example I can talk about. Sometimes what is going to happen if you are, like Vijender is not here, but Vijender is doing this thing every time. If you want to take output like this output I am observing in DSO. This is in DSO, and I don't have spectrum analyzer. Let's assume that. Actually, that's the fact of IIT Mandi also. I don't have spectrum analyzer. So I'm going to DSO. I'm plotting this. I'm taking this to MATLAB, and then I'm converting to frequency signal. But you are not going to see this one, right? So maybe I can filter out. Filtering is possible. I can filter out and I can get output. But you must have noticed that when you are filtering out, your sine wave doesn't look like sine wave. It's something like, you observe this ever, right? Because when you are doing this, it's so when you are taking the window over here or here, where the window is actually has to complete here, which is out of your actually equations. So in that case, we don't take such kind of window which is rectangular. We are going to take other window. It might have different look. This window is Blackman Harris, and that's how it will taken care of whatever the mistakes you are making in the measurement when you want to convert it to frequency domain. If you take that and if you check the Blackman Harris window, you will get less leaky output. Right? Similarly, if you are in sigma delta where you are dumping out all the noise in the output side, then you are which kind of uh, window I need to use? What do you think? So this question is for Himanshu because he is designing sigma delta. So rectangular will not work. It has to be Henning window where the actually noise will be dumped out to the output side. Right? It's a different theory. So it depends on your application, which application you are using. But if the application is not defined, use rectangular. Right? So this is how it will work. Any question in this one? Okay. Anything which I need to teach? Okay. So other than that, if you are actually passing your circuit from a non-linear device, you are going to observe harmonics. First of all, my suggestion is whenever you are dealing with any non-linear circuit, and if you are interested in something called SNR, THD, or anything which is harmonic related thing, you need to check whether your sine wave is leaky or not. First of all, you are going to see the FFT of sine wave, where you are going to see only one impulse at the input frequency. Other things will has to be at minus 300 dB. Do not plot this in linear scale. If you are plotting at linear scale, everything will be zero. There is no problem, right? It will look good, but it's leaky. So we don't call it wrong one, but it's leaky one, right? So you need to check that. Once you are getting the input as just one beam and other are at minus 300 dB, then you should use the same settings and you should check what is happening at output. So for that, look, only input is getting amplified or getting attenuated on the basis of what your slope of the or gain of your amplifier, and others are the harmonics. So this is known as second harmonic, this is known as third harmonic, fourth, fifth, sixth, and you should check till where you are getting minus 300 dB. But still, this theorem, what I am saying, it's only limited to cadence, right? If you are looking for MATLAB, it goes to minus 600 dB, and the numbers of harmonics will be increasing, right? So this is called fundamental. So signal to noise ratio is basically the average of all of these and signal amplitude. The ratio of these two is going to give you signal to noise ratio. Right? Other thing, if I'll touch, then yeah, everything, everything. After sometimes it's everything is minus 300 dB, right? So average of whole noise floor is minus 300, and average of all these will be above minus 300 dB, right?
So in case where SNR is defined, given some band, so like if we consider all the spectrum, so the average will be very lesser. If we remove some, the average will goes up.
But when we are doing this,
And
look, it's not only the plot till sixth harmonic.
yes,
It's means let's say this is seventh harmonic. Then where will be the eighth harmonic? If this is Fs by 2, eighth harmonic is here. Means after let's say there are 4 5 cycles, so eighth is here. Then after 1 2 3 4 5, ninth is here. 1 2 3 4 5, and then you can see there are all the harmonics have been plotted actually, maybe till 100.
after omega it will repeat.
Of course, it should go inside. This is called frequency wrapping, right? It should go back. So these are also the harmonics, right? So right, you have to take enough cycles and enough number of points. Those points has to be okay. So I'm telling you this. If it is radix 2, it has to be 2 raised to n. Maybe once you have the, once you will plot it, if you want to know the algorithm, I'll tell you how to choose these numbers, right? So I'll share with you how to get the correct answer every time. But before that, you can try and you can find out. It has to be something on Cadence forum. And this is the most important part, because we need to find out SNR, THD for ADC, for whatever we are going to design.
If we are designing something in a particular band and taking the SNR, whether we should, in case of taking the integrated noise, we should integrate
Not
it
noise is
and noise,
you're talking about noise floor or
total noise,
okay.
the power of the noise power. So integrated noise will be from in the band, or we should
Yeah,
take a
of
wider
course,
range.
you need to look at the integrated noise in the band of your interest,
Only
in the band of your interest. Because look at the output, in your case there is a filter, everything will be filtered out, so there is no problem. If something is happening like lower than what you are expecting, or higher than what you are expecting, if it is out of band, you should not worry about that, right? It will be removed out, because this filter never never look at the things that whether it's signal or what, right? It will be removed, everything will be zero, right? So anything which you want to correct, that's rule. Still I'm laughing. Do not take me negative. You can ask so many questions, no, right? If you are saying something which is wrong, then you have to give me reasoning. I might be wrong. Yeah. Yeah, but you should keep on thinking, like you should keep on giving some solutions. Like Shubham and Nishant all are participating, so all should participate and give answers. These are the fundamental things, right? Okay.